Okay, everybody can see the screen?
Yes.
All right, so we're going to start with the heparin. This is weight-based usually, and it's also based on APTT and platelets usually. On your test, you're just going to have to calculate the dose. So on this question here, it asks you about a bolus, but on your test, you're not going to have to calculate the bolus. But the bolus isn't that hard. You're administering if you read right here in this question, to administer a loading dose, bolus dose of 30 units per kilogram before you start the drip. So if it's just saying 30 units per kilogram, that would just be this times your patient's weight, which is 172 pounds, right? So you would have to convert that. But you're not going to have to do that portion. Even if you see this in a question, you're only going to have to do the what the question is actually asking you here. So for here, it's asking you start with this part of the question and read from here on every question. What is the flow rate? You will set the IV pump at in mLs per hour. Okay, so that's what we're going to answer here. And these are the ones that you're going to see. So if you're setting the flow rate on the pump, you're setting a dose. And how do you calculate a dose? Don't everybody talk at once. How you calculate a dose, nurse?
Desired over half.
Thank you. Okay, so do we have a desired dose here?
30 units. No, what's the desire?
So the 30 units is your bolus dose, okay? And then in here, you also have MD ordered for a dose, and that says 18 units per kilogram. So that is your desired dose, 18 units per kilogram per hour. The thing is, you don't know what the kilograms are yet because we haven't calculated that, all right? So for this question, you're going to need to take that 18 units per kilogram, write it down, because we're going off this screen. And the weight is 172. Write it down. And what do you have on hand? On hand, you have a bag of heparin of 25,000 units per 500 ml. That 500 ml is your vehicle, right? 25,000 is what you have on hand. So when you do desired over have, you do your desired dose over what you have on hand times your vehicle. And that's all you're doing here. All right, let's go to the whiteboard. Hopefully you wrote everything down. All right, here we are at the whiteboard. I leave everything in the calculator, okay? So I'm going to start with my weight, which is 172. And I'm going to divide that by my 2.2. Whoa, I had other numbers in there, so let me go back. All right, so I got 78.18. Now, there's a bunch of other numbers in there. You're going to leave them in there. I'm just going to put a line under this, which represents that this isn't the end of the number. But I'm not going to write all the numbers down on here. Okay, the next step is to multiply this times the ordered dose. Okay, so our ordered dose is 18 units per kilogram per hour. Okay, so we're going to multiply that times 18. And that's going to give us 1,407.27. Again, I'm going to put that line there because that represents infinity. And this is units now per hour. Okay, we have to get to mLs per hour, right? Because that's what the pump is going to be set in. All right, next thing is what do we have on hand? On hand, we have 25,000 units. And this is per 500 mLs, right? So now we're going to take and divide. Our units will cross out and we'll be left with mLs per hour. Just divide by your 25,000. You should still have everything in the calculator. And then you're going to multiply times the 500. And that should leave you 28.14. Typically, I'm going to tell you to round it to the nearest tenth. So what would it be?
28.1.
All right, I expect you to engage here. No point me teaching this if you're not going to engage. Make the mistake now because you don't want to make it on the test. And if you got it wrong, somebody else might get it wrong. Is there a 28.1 up there?
Yes, that's B.
Okay. So the other answer is 23.46. So really there, you would have just taken your weight, 172 divided by 2.2 times 30 equals 2345. Now, I don't know how they got 2346. Somebody did a math little boo-boo there or something. But the answer for that would have been 2345.45. And that's all the bolus would have been. That's just a loading dose to get the heparin up to where you need it so that you're starting with the safe dose. All right, look at the next one. Again, we're not going to worry about the bolus. I'm just talking to you about that. So when you see it, you don't freak out if you see it. I won't probably have it in the question, but if it's in there, it's going to be asking you what? Now, what is this question asking you right here? This is what you should be reading, not the top. Because this tells you how to set the problem up. So what is it asking?
The flow rate.
What
ml
is
per
the
hour.
flow rate you would set the IV pump to at mLs per hour? So that means you're setting up the dose. And if you're setting up the dose, what's the formula?
Desired over half.
Desired over half. Okay. So no matter what is in this question, all you need is the stuff that would set up the desired over half. Okay. So what do you have?
All right, 16 units per.
No. What do you have, nurse? What do you have? What's a given there that you have on hand?
12,500 units.
Okay, you have a heparin bag
Units times
with
kilo.
12,500 units per 250 ml. I'm just showing you the easy way to do this, the question, okay? You have a bag with 12,500 per 250, and you're going to write that down because that's the bottom part of your equation, right? Now, the other part of your equation, which I just heard someone say, is that 16 units per kilogram per hour. But that's part of your desired dose, right? So in order to get the desired dose, you also need the patient's weight. So you're going to write those two things down, the 198, the 16 units per kilogram per hour. All right. You don't need anything else in that statement to do the question. You can read it now. But it's not asking you about the bolus here. It's only asking you about the IV pump. This is how nursing questions are written. So you just have to be aware. What do I need? If you know the formula, and that's why I teach you to read from the bottom, because that teaches you the formula. If you know the formula, then you know what you need to pull out so you don't get confused. And that's why I'm stopping you, because I want you to understand that part. All right, so we know that we had our 12,500 times our 250 mLs. That's what we have on hand. That's the bottom part of our formula. So as you're plugging it in, make it easy on yourself. You need to get to mLs per hour.
1440.
You have your weight of 198. Please don't jump ahead because a lot of people can't jump ahead. So just give us time to work it out, please. You can still work it out on your paper, get your answer, and I'm good with that. But just give me time to work it out for those that don't know how. All right, so we start with our weight of 198. Now we need to get our desired dose because this is what's going to go here, okay? So your 198 divided by your 2.2. And that gives you 90 kilograms. Ordered was 16 units. Per kilogram per hour. So we're going to take our 90 times our 16. Okay, so now you have 1440 units. This is per hour. Okay, so these cross out. This is what gives you your mLs per hour. Now we're dividing by the 12,500. And then we're multiplying by 250. And what'd you end up with?
28.8
milliliters an hour.
Okay, and it's up there, right? Now, if I asked you what the bolus was, it would be easy. You would just take that 60 and multiply times that 90. Because 90 was our kilograms. So if I was going to give a bolus here, it would be 5,400 units. Not that hard. It's not that hard. I just don't ask you to do it. But you should know how to do it. All right. How comfortable are you with these? Do you want to do another one on your own before I move on to something else?
Yes, please.
Okay, do number 6. And this is more like how you'll see them written on the test. All right, what did we get?
B 14.1.
Great. Everybody was able to get to B?
Yes.
Yes.
Anybody not able to get to B? Okay.
Yeah, not able.
Okay. So let's go over the steps. So this one was really straightforward, okay? You're going to mLs per hour. That's what it wants us to set the pump to. On hand, we have 25,000 per 250 ml. And our patient's weight is 129. We're going to divide by 2.2. That should have gave you 58.63 infinity. Leave that whole number in the calculator. We're going to multiply that times our 24 units per kilogram per hour. That should have gave you 1407.27 infinity units per hour. This is units. This crosses out, that crosses out. Now you take that whole number, divided by 25,000, multiply times 250. That gave you 14.07. This rounds that to 14.1. Okay, try number 14. Can you see it?
Yes.
This is how you'll see it on the test. Okay, there's your answer. Was everybody able to get there?
Yes.
Yes,
Yes.
yes.
Okay, anybody still not able to get there? I was looking to see if I had another one on them on there, but I don't see one. All right. Are you guys comfortable with that now?
Yes.
Yes.
Okay, next one we're going to do is this one. Okay, so this is asking how many units per hour is the patient receiving. So we know that we have a bag with 12,500 units per 250 ml. Write that down. And we know that the pump is running at 36 mLs per hour. Okay, so the first thing that we're going to do is we're going to take our 12,500 and we're going to divide that because we have 12,500 units per 250 ml. We're going to determine how many units we have per ml. And we have 50 units per ml. We're running at 36 mLs per hour. So we're going to multiply this. And our client is receiving 1,800 units per hour. Is it up there?
Yes.
Okay, try the next one.
The answer's there.
What'd you get?
A.
Okay, everybody able to get to A?
Yes.
Yeah.
Yes. No, I'm sorry. I didn't get that.
Okay. So here we have 10,000 units per 100 ml. That's what we have on hand. And our pump is running at 29 mLs per hour. So we're going to start by taking our 10,000 units and dividing it by our 100 ml. And that's going to tell us how many units we have running. How many units per ml we have. So 10,000 divided by 100 equals 100. So we have 100 units per ml. And running are 29 mLs per hour, right?
Yes.
Okay, so that gives us 2,900 units.
Okay, I got it. Thank you.
Okay, do number 4. All right, what did we get?
1250.
Okay, good job. Everybody able to get to 1250?
Yes.
Yes.
Okay, how we feeling with those? We good with those? Not, I can make another one up.
They good.
Okay. Let's look at a few of these other questions now. What about drip factors? How is everybody with drip factors? Anybody having difficulty with these?
It doesn't hurt to practice.
I about to say that. Let's do it.
Okay, let's do it. Now, for these, the thing you have to remember is just the formula. And again, every question, read it from the end. This is telling you to calculate the flow rate in drops per minute. That tells you the formula. So you should know that your formula for this is total volume. So it has to be something with the volume behind it. Okay? Over time in minutes times your drip factor, and it always has to be a whole number. That's your formula. You guys take those numbers and work on that one, and I want to pull another one up and see if you can solve it. So let me know when you got the numbers.
75 drops per minute.
Everybody's got the information out they need to solve?
Yes.
Okay, I heard somebody say the answer. 75 is correct. All right, now I'm going to reword this question a little bit. Okay, y'all see the new question?
Yeah.
Okay, now what's different about this question? Because I just told you the formula is what?
Volume over time.
Total volume over total time times the drip factor.
Okay, so what is this question actually missing?
The time.
It's missing a term.
It's missing the time.
Okay, is it missing the time?
Can I try,
No.
Miss Loge?
You can calculate it and get it.
Okay, I think you're gonna calculate 150 times 60, right?
Okay,
No.
so yeah, you can do it that way, and I'm going to work it out so you can see it, but I just want you to see this because you might see something like this. You also might not see this, okay? You also might see, okay? So now you don't have a time or a what?
Drip
A
factor.
drip factor.
So either one of those may not look like it's in the question, but it's there. So micro drip, of course, or PD drip would be 16. Let's change this back to 15 just for the purposes of the question. Okay, and for whoever wanted to calculate it, go ahead and try to calculate it. I'm going to calculate it also.
$38 drops per minute.
38 drops per minute.
Okay, great. Anybody have questions on that?
Yes. How can you
Okay.
visualize that? I don't know how, please.
All right, so there's a couple ways you could do this. They're doing it the easy way, okay? And the easy way is, in this order, it's telling you that your pump is running at 150 mLs per hour. So because you have that information, you can actually use that as your flow rate, okay? So you can use the 150, and because it says an hour, it would be 150 over 60 minutes times your drop factor, which is 15. The other way you would have to do it is calculate what 1.5 liters is in milliliters. So 1.5 times what? 1,000, right? That would say that you have 1,500 milliliters. I'm going to work it out on the whiteboard, all of it, don't worry. And it's going at 150 an hour, so you're going to divide that by 150. That gives you 10 hours, and 10 times 60 is 600 minutes, right? All right, let's go to the whiteboard. Drop factor doesn't change. So they're doing a shortcut step, okay? We know that we have 1.5 liters. And we know that we have a drop factor of 15. All right. What we didn't have is the time, but it told you the pump was running at 150 mLs an hour. So it's running at 150 mLs over 60 minutes. You could have just put that, multiplied this times the 15, and what was your answer? 37.5. And then they rounded it to 38 because it has to be a whole number. Okay. Now, because it says that the formula is total volume over total minutes, if you use that formula, this is actually your total volume. So that would convert to 1,500 milliliters. But this is not your total minutes. This is only your minutes over 1 hour. Okay? This pump is running at 150 an hour, so it's going to run over 10 hours. So if you use your total volume of 1,500, then you have to use your total minutes, because 10 hours times 60 is 600 minutes. Times your 15, you still should get 37.5. Do the math.
Thank you.
Okay, so they just cut the step out because that little quirk was in there, and you could do that with that problem. you may see problems written in a variety of ways, and it's not just us who writes them that way. NCLEX is going to write them that way. You're going to see them on nursing exams that way.
Miss Lewis, can I back up real quick? On your micro drip, you said it was, what'd you say the micro drip was?
Micro drip and PD drip are both 60.
Okay. Thought you said something else. I was thinking that's 60, isn't it?
Yeah, it's 60. So if they don't give you a number there, they're going to either say micro or PD, because those are the only two drips that we don't give a number for. Everything else is a macro drip. So it'll be 10, 15, 20. It'll be written out in number. Just talking about the size of the drop. And PD drips, we wouldn't give the same size drops as adults, right? Because you have to be very careful with them with fluids. They're 90% water, which means any fluid imbalance in a pediatric child is going to have a big impact on their body. All right. This is just another drip factor. Go ahead and do it.
$43 drops per minute.
Okay, good job. Anybody still working? Anybody need me to stay here for a minute?
Now,
All right. Again, when you see a question like this, forget about all the words in it. Just look at the last statement. What does the last statement say? The nurse sets the infusion pump at how many milliliters per hour? Now, why are you setting the infusion pump at mLs per hour? Because you need to deliver what? A dose, nurse. You need to deliver a dose. That's all you give is doses, right?
yes,
So if you're given a dose, what's your formula?
desired overhead.
Desired over half. Okay. I always go to the given. What's the given? So, you know, for this one, you have two givens. But the main given I look at first is what do we have on hand? Because that's what I'm going to put on the bottom. So what do I have on hand here?
20,000 units.
For 250 ml.
Yes.
Okay. And my pump is running at what? I mean, my prescription is for what? I'm sorry.
1,500.
100 units.
1,500 units an hour. Now look at my stuff. Look at what I have on hand. Look at what my prescription is. On the top, on the bottom, I'm going to have units. So that can cross out, right?
Yes.
And that's going to leave me with mLs per hour, right? mLs from my vehicle of 250 and the hour because I have 1,500 units per hour. So I can simply just set my problem of desired over half here. My 1,500 over my 20,000 times my 250, the units will cross out and I'll be left with mLs per hour, which is what it's asking me for. So take your numbers, 1,500 and 20 per 250. This is where I'm trying to get to, so I always try to put this at the bottom. You can break this down as much as you want if you know how to break it down, you know, by eliminating things. Oh shoot, where did I write that at? It was 20,000 units per what?
250 ml.
Guess I gotta get a new paper. Can't see nothing on that one anymore. All right, so for me, I would even, like if I have 2 zeros here and 2 there, I'm gonna cross it out. And now I got 15 divided by 200. Just to make the math easier, you're still gonna come out with the same answer. Cross it out, whatever you can. All right, this is units per hour. So you're gonna be left with mLs per hour. It's whatever you do, just do it consistently, and it's whatever makes the most sense to you, because what makes sense to me might not make sense to you. Now, what'd you get here?
18.8.
Okay. Round to the nearest tenth, right?
Yes.
Can't panic when you see the words. If you know what the question's asking you, then you know what to set up for the formula and you know how to do the math. But you have to be consistent, and if you're not good at it, you have to practice it. If you don't get it mixed up, because it's going to bounce back from one kind of question to another kind of question.
How many questions are going to be on the quiz, Ms. Lowe?
Usually there's 15. Right now I'm going over Geri's stuff, then I'm going to go over the med surg. There's a couple of differences between those two tests, but if you can pass one, you should be able to pass the other. All right. Again, this is just asking you how many mLs you're going to give to the client. If you're giving mLs to the client, you're giving a dose. So you know it's going to be desired over half. And you have to go in your formula and look and see, is everything the same? Because if it's not the same, what do you have to do?
Convert it and make it the same.
Okay, so this is conversion right here. Do you know which way to convert? And you should be able to imagine the scale. If you can imagine the scale, you're good to go. Here's your scale. I don't care if it's one time I put microliters on the test and people freaked out. I'm like, why? Okay, you got kilograms, grams, milligrams, micrograms, okay? The same thing, right? Liters, milliliters, microliters, it's all the same. Right? Kiloliters. Whenever we're going to the right, we're going to act like a rabbit, and we're always going to multiply. You can see the scale, you know you're going to the right, you're going to act like a rabbit and multiply. Whenever you're going to the left, you're losing the love of your life, you need to divide. Oh, divide. Divide, Sue, divide. Okay? And just try to remember that in your head whenever you're doing the math. If the math makes it hard for you, then you can always do move the decimal, okay? So I have 0.5 liters. I'm going to the right. If I'm going to milliliters, I got to move the decimal. 1, 2, 3. Put 2 zeros there. Now I have 500 milliliters. You could double check yourself that way also. Just say, let me just double check myself and make sure that I'm doing it the right way. I also use a lot of little simple rules when I'm doing my math just to double check myself. Because I make my math mistakes on the stupidest math, not hard stuff. On the simple ones, because, I'm calculating or my brain's moving fast. Sometimes I got to slow it down. Get it out of my manic mode and into my slow down and do a safe dosage calc. All right, so who tried to solve this while I was talking?
25.
25.
All right, so again, I'm talking about the same thing here about moving the decimal or dividing, okay? Here's what you have to remember when you're doing the math, okay? It doesn't matter which way you go on the scale. Like I could have converted the milligrams to micrograms or vice versa. I don't really like working with decimals. So if I have a decimal in my statement and I can convert, I'll convert to get rid of the decimal. If you're in real life, okay, and I have milligrams on hand, I can't convert that to micrograms. I would have to convert the order. But on math, it doesn't matter. I'm going to convert whatever is easiest for me to remember, whatever is easiest for me to do. Be consistent with your methods. That's why I try to teach you formulas. If you consistently know the formula, you won't get the math wrong because you use the same formula all the time. It's like, going to the store all the time. You learn the steps, you repeat the steps. This is why Department of Health can tell when people fake it on med passes, because we watch people all the time. We know when you're doing something consistently and when you're fumbling, not because you're nervous, because you don't do this all the time. All right. So this is asking you to do what? Come on, what's it say?
It's asking for how many milliliters per hour.
To deliver the prescribed dose, right? If we're given a dose, what are we doing?
D over H.
Yeah.
Okay, D over H. So let's see if you can solve this. It don't matter what it is.
$15.
Okay, and no matter how you do this, that's what it's going to come out to. Okay, even if you took the 25 units and divided it by 25, it's still going to come out to 1 unit per ml, right? So it's going to be 15 units per hour, no matter how you do it. Anybody have a problem with that one?
No.
Uh-oh. That's where people have a hard time. So a lot of things you got to read here, okay? So it's asking for the 12-hour intake 7 to 7. So you have to make sure that your numbers here are within that period. Okay? We're going from 7P to 7A. So 11P does fall within that. This falls within it. This falls within it. So you want to go down first and make sure that everything falls within it, because if not, you want to cross it out or get rid of it. All right? All right, this is running at 100 mLs an hour for 12 hours, so that's going to be 1200. Make sure when you read across here, this is just one bag at 250, right? So that's 250. Everything here, I'm also looking for to make sure it's either in mLs or ounces, because I might want to separate the two if it's easier for me to do that math. 30 mLs of a saline fudge, that counts. One-time order of Zosyn, 100 mLs, that counts. 50 mLs of saline, that counts. Now, how much is this last one worth? How many mLs is that?
240.
40.
Anybody disagree with that? Who's confused? How much is 1 cup worth?
240 of water or ice?
How much is
8
1 cup
ounces.
worth?
Cup of water is 240. So half of it will be the ice, which will be the 120.
Okay, nurse, all I'm asking you is how much is a cup equal to? Don't equate it to a
Oh.
solution, because
Okay,
we don't
sorry.
do that, okay?
Okay.
When we look at a cup is 240 mLs, period. Okay? Why is 2 cups here then for 240? Now you can tell me.
Because when it's ice, it's cut down in half.
Okay. So just in case somebody doesn't know and doesn't want to say they don't know, this is worth 240, because if it was water or any other substance, it's 2 cups, it would be equal to 480. But here we're only having half, because ice is only equal to half. So that's why they put the 240 there. All right, so everybody understands that concept. Now you can just add all that up, okay? And that would be your intake. It's not going to match what I have on the answer because I added 240 to it, but let's see what the answer has. We can add 240 to it.
1870.
$18.70 is perfect. That's exactly what it would be with that ice. Okay, and then we also, like when you get up into the higher level, you'll have to tell me, is this positive intake or negative? So what do you think? Look at your numbers down there.
Negative.
Okay, we have more output than input, so it's negative. So this will put our client at risk for what?
Hydration.
Dehydration.
Dehydration, fluid volume deficit, things like that. If we're positive, then we'd be looking at renal failure, some sort of urinary retention, heart failure. All right, again, this is just the same thing, right? Administer the dose. As soon as you see that, administer the dose, you know the formula, right?
Yes.
Everybody's good with this one?
Yes.
Okay. This is asking you how you would set the pump in mLs per hour. All right. And the only thing you have here is the doctor's order. You don't have anything on hand here. Okay. So now you're just gonna, this is just gonna be your total mLs over your time in hours. The problem here is your time is what?
Minutes.
Okay, so you have to convert it to hours. So we have 800 mLs over 120 minutes. Now, you already know that this is equal to 2 hours, so you could easily just say, okay, this is 2 hours. What if it was 48 minutes? Okay, then what would you do? So the easiest way to do this is 800 divided by the number in minutes times 60, that automatically converts. You'll get the same answer. Try it. 800 divided by 120 times 60, or 800 divided by 2 hours. Did you get 400 both ways?
Yes.
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 So what
it's-
way works best for you? This is the easy way. If it's in minutes, convert it at the end. If it's in hours, then you don't need to convert, because it's already in hours for you. Okay, so let me see if I can find a couple of those for you to practice with real quick.
Miss Loge.
Yes.
Okay. This is a silly question, but I
It's
just want to
not,
mention.
it's math. It's ask it now. It's a silly question if you ask it when the exam's going on.
Yeah, because sometimes you be putting round to the nearest whole number, and sometimes the number is like this, like 7. For example, one of the questions, the answer was 7, and it says round to the nearest whole number. So for a minute, I was like, it's only 7. So what am I rounding? I didn't know what to round. Eventually, I put 7, but it really, like in the beginning, I thought I was wrong after when I worked it out. So I don't know. The distractions is just.
Well, you better get used to that, because a lot of nursing questions are going to tell you to round it to the nearest tenth, and the answer might be a whole number. You don't change your number to round it to something. So if you already have a whole number, then what would you change it for? What would be the reason?
No, I just, because of course we didn't have the multiple answers. I thought that maybe I worked it wrong. Is what I'm trying to say.
Yeah, you're not going to have multiple choice answers. I just use these for the practice part.
No, no,
You're not going to have multiple choice. But you will have nursing questions, because I don't write all the nursing questions, and there are nursing questions out there, tons of them. Okay. These are jet factors. I don't want these. That are going to tell you to round, and the number, once it comes out to the number that you need it to be, unless it's in the nearest tenth and it's telling you to round it to a whole number, then of course you're going to. But if it tells you to round it to the nearest tenth and it's already in the nearest tenth, then you already have it in the correct format.
Yeah, Ms. Lodge, because there was a math question that we had that the answer was 0.5, and it said round to the nearest whole number. When we rounded up, you round it up, it became 1.
Yeah, but on that question, you got the answer right. It wasn't marked wrong for you.
No,
That
it
was on a
had
practice question. So if there's an error on the question, like if I tell you to round it to the nearest whole number,
right.
and it should be in the nearest tenth, you're not going to get marked wrong for that. But
Was
if
it-
it tells you to round it to the nearest tenth and it's already in the nearest tenth, you're not going to change it. If it tells you to round it to the nearest whole number and you end up with a whole number, you're not going to round it or change it. Do you get that point?
I do, but that one we did get it wrong, you know, and I remember one
You
of my
didn't get something wrong unless it was a wrong answer. If you show me the question, I'll prove the point to you, because you don't get anything that you prove to me is a right answer. You get credit for it.
yeah, Miss Loge, it was health assessment. The not the first, not the second, but the third dose calc. One of them, because I got 90, but that particular one was 0.5. So of course I rounded up to make it 1. So it marked me wrong.
Again, I got to go back and look at the question. Did you challenge me at the time of the question? Did we look
I
at the
think
question?
I even spoke to Miss Brown, and then Miss Brown was like,
Because I wouldn't mark your question wrong if you put a right answer there. We'll take this off screen, okay?
okay.
Because that's not true. I don't ever mark you guys wrong for something if you're right. If you answered the question wrong, then you got it wrong. But I wouldn't do that on a question. If I write the question wrong and I key the question wrong, you're going to get the answer right. Because I don't do that on the math.
When I get a chance, when I get to school and I see you, I'll show you what I meant. That
Absolutely. We're going to look at it.
okay.
Because if I'm wrong, I will always take accountability for that. I would never cheat you. I don't want to ever cheat you out of something that you deserve. And I know I write a lot of math questions. I write a lot of them late at night. So if I'm wrong, I will always give you the credit for where I'm wrong. And I want you to understand that so you don't freak out on the test. I work really hard to try to make sure that your questions are fair now. And I think you can see the difference in the math over the last 2 terms versus what it used to be. But also, in all fairness, you guys go practice your math. Okay? A lot of you are very weak on the math, and this is something you have to practice all the time, these formulas. Because when I ask you formulas, you can't even tell me formulas. You have to know formulas. That's how you solve. And if you can't read the question and determine the formula, that's always going to be an issue for you. Now, rounding is also a problem for you guys. And that's something we need to work on. Because sometimes you don't know when to round it and when not to round it. So even on these, look at this one here. This is the drip factor, right? On these, I even tell you to round it to the nearest whole number, which I shouldn't do because really that's sort of cheating. Because you should automatically know that. I shouldn't have to tell you that on this question because these questions are always round to the nearest whole number. But if I didn't put that on there, you know how many people would get these wrong? But I try to be fair as possible. All right, let's move on. All right, let's go to the reconstitute. Well, how were we with the pump, with the milliliters per hour? Because we really didn't finish that. So again, if you look at this one, the difference here is your time is in what?
Hours.
Hours. So you don't have to do anything here. And it's asking you what's the hourly rate on the pump. You notice that you only have the order. You don't have anything on hand. Okay? So here you're just using your total volume and your total number of hours. So what am I looking at in the question here? I'm looking at what the question's asking me, which is it's at the hourly rate on the pump. I don't have anything on hand. All I have is an order that tells me my volume and how long I'm going to run it for. Okay, so here it's going to be volume over time. My time has to be in hours, or I have to convert at the end if it's in minutes. All right, we were going to practice some of those. All right, let's start with the second one. Can you see it?
Yes. The answer's there.
Everybody done? Anybody
You-
still working?
Yes.
No.
Okay, what we get?
42.
42.
Okay, everybody's good with the rounding up at that part, right? You notice that one doesn't tell you to round up. Okay, but on my test, I would have told you to either round to the whole number, or I should be telling you here. When you get a number like this, 4.166666, if I'm writing the test, my intent is to tell you here to either round it to the nearest whole number or round it to the nearest tenth. Okay, because you can't assume on an answer like this when I'm asking you to set the pump that I want it at a whole number. So on these, I try to make sure that I put in there round it to the nearest tenth or round it to a whole number so that you know what to do. All right, because it's not landing on a whole number. All right, look at the next one.
The answer's there.
Anybody still calculating? We're good?
Yes.
Okay, so you see how they flip-flop? They'll flip-flop back and forth, just like this. Okay, go to the next one down here. All right, what did we get?
C.
C.
Okay, anybody struggle to get there? Everybody's good.
I have a problem there. I have 1.067 and I don't understand how I got the point there.
You have 1.067.
Yeah.
Okay, did you convert the 0.8 into 800?
Oh, no. So that's the problem. All right. Thank you.
Anybody else? Okay, how about the next one? This is where people make the biggest mistake here now. What do you think it is?
They use in milligrams.
Okay, which is a strength. And so you can't use that because that's the strength of what's in that milliliters. So you got to make sure you use the mLs here.
The answer's there.
Okay, everybody done?
Yes.
All right, what did we get?
A.
87.5 milliliters an hour.
Okay, how we feeling with those now? We good?
Good.
Good.
Okay, look at number 11. This is reconstitution. Okay. Whenever you're reconstituting something, you're getting usually a powder and you're adding a liquid solution to it. The most important thing here is what you're left with on hand. And it tells you that. Final concentration, final solution on hand is your final supply. So what is our final constitution here?
300 milligrams.
Per ml. And then what's our desired dose? Because this is just desired over half.
500 milligrams.
So you're just going to put one on top of the other. That's simple.
1.7.
Anybody need me to show them that?
Yes, can you show me, please?
All right, so here, all this, don't worry about it. What you want to worry about is this. Because this is saying how many mLs milliliters give. And you only give what? Doses, right?
Yes.
When you're giving something, you're giving a dose. So whenever you're given a dose, it's desired over half. All right? So this is our desired dose. Our final concentration is what we have on hand. Desired is, oh, let me go back and look at that again. Make sure I didn't put it backwards. Our desired dose is 500. And we have 300 per ml. Now for me, I would just do this. I know 3 will go into there once, so I know this answer is going to be 1 something, right? That's how I double check myself with little math. $1.666. Get rid of the devil. Round it up. 1.7.
Got it. Thank you.
Okay, this one's the same way. Try it. Now, again, it's asking how many mLs will you administer per dose? So right away, that tells you the formula, right? Then you see your final concentration and you see your ordered dose. Everything else in there doesn't matter. It would come like that, but it doesn't matter for solving.
You want the answer?
Yes, I do.
7.5.
Okay, how we doing? Everybody able to get there?
Yes.
I don't know, registered nurse, she has some reconstitutions, hers are a little more in-depth, I believe. Than what I ask you to do. Let's see, there is another. I gotta find it, I have it somewhere. It's a sheet with about 11 problems on it, and it's just reconstitution. So I'll see if I can find it. All right, so how do you guys feel about those ones?
Good.
You wanna try a couple?
Sure.
Like you understand it.
Yep.
Let's see, I don't know if I have any on of those on the med surge one, let's see. All right, here's one on the. Number 12.
You want the answer? You want the answer?
Sure.
3.
Okay, everybody able to get to that?
Yes.
Okay. Look at a couple other questions. I wanted to go over a weight-based one. And then we'll go over some of these ones here on this one. All right, can you guys see my question sheet?
I'm looking at something that's in between insulin questions, I think.
Okay, how about now? You see question 15.
Yes.
Okay. So this one here is asking you what rate you're going to set the IV pump to in mLs per hour. Now, we already said whenever you're setting the IV pump in mLs per hour and you have a desired dose plus an ordered dose, what is going to be your formula?
Desired over half.
Desired over half, because you're still given a dose here, right?
Yes.
Okay. So you do have something on hand. What do you have on hand?
400 milligrams and 500 mLs of dopamine every 500 mLs.
Okay. And you have an order to calculate your desired dose. Okay. Now, here's the problem. Your desired dose is going to be in micrograms and it's going to be per minute. And you have to get to mLs per hour. Okay. So the nice thing is your weight is already in kilograms here. So write your weight down and write down the order, which is 20 micrograms per kilogram per minute. Okay, so we're trying to get to mLs per hour. Our patient weighs 80 kilograms. We have 400 milligrams for 500 mLs. And our ordered dose is 20 micrograms per kilogram per minute. Okay, so 80 times 20 is going to be our first calculation. And that tells me that I have 1,600 micrograms per minute. All right, I want to go to milligrams. So I'm going to go ahead and divide this by 1,000. I'm going to the left. All right, or I can do 1, 2, 3. So that should have given me 1.6 milligrams. Is that correct?
Yes.
So I have 1.6 milligrams per minute. Okay. I need to get this to an hour. So I do that by multiplying by 60. I also need to multiply my 1.6 times 60. That should give me 96 milligrams per hour now. Okay, milligrams is going to cross out. I'm going to be left with mLs per hour. Now I can divide by the 400 and multiply by the 500. And that should give me 120. Everybody there?
Yes.
Yes.
Let's see if we got it right. Okay, this is going to be a similar question. Okay, it's asking us how many mLs per hour to administer. We have something on hand. We have an ordered dose. So we know that this is going to be what formula?
Desired overhead.
Okay. So what we have is what?
4 milligrams per
4
ml.
milligrams per ml. And we're going to calculate our desired dose. So we're going to write down our 30 micrograms per kilogram per minute and our weight of 176 pounds. So our weight is in pounds. We're going to have to do one extra step here, and that's convert the weight. And we're going to leave everything in the calculator when we do it. So I'm trying to get to mLs per hour. On hand, I have 4 milligrams per ml. My patient weighs 176. And we have 30 micrograms per kilogram per minute. So 80 times 30 gives me 2,400 micrograms per minute. I need to get to milligrams. I'm going to divide by 1,000. That gives me 2.4 milligrams per minute. I need to get to hours. So I'm going to multiply both sides by 60. It gives me 144 milligrams per hour. Milligrams crosses out. I'm left with mLs per hour. Going to divide by 4, and it's times 1. So, of course, it's going to remain 36. Everybody able to get there?
Yes.
Yes.
Miss Loesch, let me see the question again.
All right, we're going to try some on your own now.
Miss Loesch, can you go over it one more time? Because I missed it.
Okay, let's look at number 1. So it says how many mLs will you administer? Okay, we see that we have something on hand and we have an ordered dose. So that tells us that our calculation is going to be desired overhead. So first, I'm going to take out of the statement what I have on hand, which is my dobutamine, 250 milligrams. for 250 ml.
Excuse me, Ms. Lowe's, you want another problem? Because I'm looking at a lot of Kane question.
Sorry.
Are
What
you
see
doing the
now?
lidocaine or okay?
What you see now?
Question number one.
Okay. Let me start from the beginning. All right, so it says how many mLs per hour will you administer? Okay, and then I look up here and I see that I have an ordered dose and I have something on hand. So that tells me it's going to be desired over half. So I'm first taking what I have on hand, my dobutamine, 250 micrograms for 250 mLs. I'm writing that down. And then I have an ordered dose of 4 micrograms per kilogram per minute. I'm writing that down. And I have a weight of 198 pounds. Writing that down. Now I'm going to the whiteboard. Okay, I know I need to get to mLs per hour. I know that I have 250 milligrams per 250 mLs. My ordered dose is 4 micrograms per kilogram per minute. And my weight is 198. I'm going to start with the 198 and I'm going to leave everything in the calculator. And I'm going to take the 198 and divide it by 2.2 to convert my weight. And that gave me 90. 90 kilograms. I'm going to multiply that times my 4 micrograms. And that gives me 360 micrograms per minute. Okay, I need to get to mLs per hour. So now I have to convert my micrograms into milligrams because that's what I have on hand over here. So I'm going to take my micrograms divided by 1,000. Remove the decimal, 1, 2, 3. And that gives me 0.36 milligrams per minute. I still have to get it to milligrams per hour. So I'm going to multiply my minute by 60 and my 0.36 by 60. That's going to give me 21.6 milligrams per hour. Milligrams crosses out, I'm left with mLs per hour. Okay? And if I do the math here, this is going to cross out, right?
Thank you. I got it.
And that was our answer. We're going to stay on these for a minute and then we'll come back and do these other ones. Okay? There you go. See if you can solve it. Number 3.
61.
Okay, is anybody else still working?
Yes.
Let me know when you're done.
Okay. Yeah, I got it.
Okay, anybody else?
Same.
Okay, I'm gonna put this one on the board so we can see. So we're going to mLs per hour. We have 4 milligrams per ml on hand. Patient's weight is 298. And we're ordered 30 micrograms per kilogram per minute. So it's going to be 135.45 infinity. We're going to use that whole number, whatever it is, all them 4 5s times our 30. That's going to give us 4,063.63 infinity micrograms per minute. We're going to divide here to take it to milligrams. And it's going to give us 4.063 milligrams per minute. We're going to multiply by 60. That gives you 243.81 infinity milligrams per hour. Cross out our milligrams. Divided by 4 gives us 60.95. This would round this to 61. Okay, everybody was able to get there?
Yes.
Yes.
All right, number 10, do number 10.
The answer's there.
Anybody still working? Okay, what do we got?
D.
D.
Okay, good. All right, let's see what else we got on here. All right, how about number 2? What's the formula here?
Diet over half.
Okay. Let's practice it.
You want the answer?
Yep, and I'm gonna throw it up there. Everybody's good with that one? 0.9, is that what you got?
Yes.
Yes.
Hey, how about this one?
14.
Anybody have any difficulty reading that? That's just the drop factor. So is that, but I put microliters on there. Just messing around, okay? You won't see microliters on the test, but I don't know why I put that on there. You just had to convert it though. All you would have had to do was divide it by 1,000, okay? And it would have brought you to milliliters. Late nights, early mornings. All right, look at this one here.
10 units.
Everybody good with that?
Yes.
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 Same thing here.
6 units.
Eyes and nose. The main thing we went over is the ice, because that's usually the one that people mess up on. And you also have to look for anything that says continuous. Okay, how about these ones? What do we get?
Was it 12 hours?
So it's asking you to calculate the completion time. So you have to
Yeah.
tell me what time in military time did the IV stop?
So
2,300.
Okay. So the first thing you have to do is determine how much fluid is left in the bag, which was 900. And it's running at what speed. 75 an hour. And it started at 11 a.m. So you already know 11 to 11 is 12 hours. What if it was 9.6 hours? What time would it end? How would you calculate that if it was 9.6 hours? So you have to take that 0.6 and multiply it times 60. Okay, so that would mean 9 hours and 36 minutes. And then you would add that on to whatever your time was. I want you to know that in case you see a question like that. You might not, but you might see one on the exam. They could put it anywhere. Everybody good with that?
Yeah.
Yes.
All right, what's your answer here?
$500.
Okay, everybody's good with those ones?
Yeah.
Yes.
Yeah.
All right, this is the med surg one I'm going over now. How about this one? So two answers you got here, the regular IV rate and the piggyback rate. All right, where we at? How we doing?
The IV flow is 277.
Okay,
Yes, 277.
and the piggyback?
133.
Okay, everybody was able to get those two numbers?
Yes.
Yes.
We did this one. Okay, we do this one. We didn't do this one. Oh, this has a problem though. Let's make this milligrams. This probably was, I don't know if that was milligrams or not, but that's what we'll use, and I'll do the calculation and make sure we have a right answer here. No, this was probably grams. All right, so start over, make this grams.
One point three.
Okay, good. Everybody able to get there?
Yes.
Yes.
Okay, this is just a regular weight base, so you should be able to do this one. You notice that everything here is what? What's the difference here between this one and the one that we just did?
They asking for mLs per hour.
Well, the answer was mLs per hour for the other one too, but look at your strengths and look at how your order is ordered. Here, it's already in milligrams and it's already per hour, the order. So you don't have to do those conversions, and this is where you have to pay careful attention. Plus your weight is in what here?
Kilogram.
Kilograms.
Kilograms. So a lot of steps you don't have to do here. It's still going to be desired over half, okay?
Yeah.
Okay.
187.5.
Okay, good. 187.5. Anybody have an issue there?
Yes, Ms. Loesch, could you please work that one out?
All right, so when it's asking us the flow rate and we have an ordered dose and we have something on hand, we're going to use desired over half. We have 50 milligrams per 250. And what's ordered is 0.5 milligrams per kilogram per hour. We have 75 kilograms. So it's our weight times the ordered dose. Over what we have on hand. Leaves us mLs per hour. To 187.5. Here's a similar one. See if you can solve it. What's the difference here?
The weight has to be converted.
Okay, and what else is it telling you to do as far as the rules at the end?
To round to the nearest hundredth.
Okay, so those two things you have to take into consideration when you do the calculation. Okay, what do we end up with?
0.8.
Already you didn't follow the rules, nurse.
0.845.
Okay, also did not follow the rules. What does it say?
So
0
round
point
to the nearest, 100. Sorry. 0
0.85.
0.85.
Okay, good. Let's see if I follow the rules. .85. I don't know where the hell this is, what this is from, but that's something else. That ain't that calculation. That's probably right. Oh, I guess that wasn't the end answer. That probably wasn't the end. The answer's down here, probably somewhere. All right, so anybody not get that answer? 0.85. I mean, you guys got the answer, you just didn't round it correctly. Anybody have a problem with that? So just remember when you're rounding, okay? There are times when we do have to round it to the nearest 100. This is 1,000. 100. This is the nearest tenth, but they also refer to it to the nearest decimal place. On the test, it might say round to the nearest decimal place. If it says that, that means this. I don't write it like that, but other people do, so you might see it on an exam like that. So this dictates this dictates this. If you're rounding to the nearest 100, you got to use this. All right?
yes.
All right, that was it for that one. Any other questions? Anything I didn't go over, somebody's not sure of?
No, thank you for all the help.
All right.
you.
Thank you.
Now, who is on here? Miss Frazier, you're the one that had a problem with that dosage calc. You and one other person. If you guys want to stay on, I want to look at that.
Yes, please.
Miss Lush.